Okay, let's look at game number 3 from PrepTest 93, and be sure to hit subscribe for many more explanation videos of official LSAT prep tests. For a group show, we are selecting 5 of 8 paintings. Okay, so we have 8 variables here. We're going to write them out like we do at the beginning of every game. We have F, G, H, I, Q, R, S, and V. And it seems like we're just selecting some of them to be part of a show, and then some of them are going to be not selected. So that's a selection game, or an in and out game, which is a grouping game that has 2 groups, an in group and an out group, right? So generally speaking, with in and out games, we're just going to use check mark and X instead of letters, right? We could use, let's say, G for show or an N for not show or something like that. But because there's already so many letters on the page, we might as well just use check mark and X. That's usually what we would do to show in and out. So we are given exactly how many go into each group. We have 5 in the in group, which means we're going to have 3 in the out group. It's important to show both groups. When you have an in and out game, you want to show not just the in group, but also the out group, so that we can make deductions from one to the other. So let's go ahead and write out these rules. I see a lot of ifs, which means there's going to be a lot of conditional statements here. So if either or both of G and H are selected, Funscape is selected. So if either G or H is in, then so is F, right? The arrow means if what's at the beginning of the arrow is true, then what's at the end of the arrow is also true. That's how we show if-then statements. So if either G or H are in that in group, then F would have to be there as well. Next, if V is in, then Q and R are both in. So another rule in the in group, if V is there, then Q and also R are going to be in. Next, if H is selected, so if H is in, this time it's pointing to the out group, because if H is in, then neither Q nor I are selected. So Q and I are both going to be over there if H is in. Next, if both G and S are selected, I is not. So if G and S are both in, if they're both in, so G comma S, if they're both in, then I is out. A lot of interesting conditional rules on this game. And then finally, if F is selected, then exactly one of S or V is selected. So if F is in, then we have one of S or V. So that's one or the other, but not both. That's a hard or as opposed to a soft or. In other words, we have one or the other, but not both. So S, we'll just write it out like that. S or V. That's usually how we would write a hard or like that. We would write out the word or and underline it to emphasize that it's one or the other, but not both. That has to be in. So if F is in, then S or V have to be in, and the other one has to be out, which is another way of saying that S and V are split up, right? One of them is going to be in, one of them is going to be out. That's the rule that's triggered by F being in. Okay, so we have a lot of ink on the page here, a lot of kind of wordy conditional rules, but we know how to apply conditional rules, right? If the beginning of the arrow is true, then the end of the arrow is true. And also, the contrapositive of every rule tells us that if the end of the arrow is false, then the beginning of the arrow would have to be false. So with that in mind, let's go ahead and look at the questions. Number 13, which of the following is an acceptable list of the 5 paintings selected? So this is a simple acceptability question where we're given 5 scenarios and we have to go through all the rules and see which one follows all the rules. So as always, we're going to start with the first rule. We're going to go through the rules in order, and we're going to look for all the answer choices that break that first rule. So the first rule says that if either G or H is in, then F has to be in. And they're giving us the ones that are selected, right? So that means if G or H is one of these 5, then F has to be also. So A, I see that G is in, which means F should be also, which it is. So A follows that rule. B, neither G nor H are in, so that rule isn't even triggered, so B certainly doesn't break that rule. Right? That rule only tells you something if G or H are selected. C, I see G is not there, but H is. H is selected. which means F should be there, which it is. So C follows that rule. D, I see G and H are both there, which means F should be there, but it's not, right? So D triggers that rule but breaks it, right? Because G and H are both in, but F is not. And then E, I see G and H are both in, and F is in, so that does follow that rule. So we'll move on to rule 2. We don't have to do the rules in order, right? Generally speaking, we can pick the easy rules to start with. It just happens to be these rules are all kind of equally tricky. They're all conditional rules, so we might as well just go in order. So that was rule 1. Let's go to rule 2. If V is in, then Q and R have to both be in. So if V is selected, in other words, if V is on the page, since they're giving us lists of the letters that are selected, if V is one of them, then Q and R have to be also. A, V is not one of them, so that rule isn't triggered, so nothing to worry about. B, V is also not one of them, so it also doesn't trigger that rule. And again, if it doesn't trigger the rule, then it certainly can't break the rule. So A and B are both fine. C does trigger the rule. V is there, which means Q and R have to be there also, which they are. So C follows the rule. D we already crossed off. E, V is selected, which means Q and R should be there, but they're not in E, right? V is in and Q and R are not both in, therefore E breaks that rule. So we're left with A, B, and C. Let's move on to rule number 3. If H is selected, then Q and I cannot be. So if H is in this list of 5 letters, then Q and I cannot be. They both cannot be. A, H is not selected. H is not one of the 5 in A, so that doesn't even trigger the rule, so we don't have to worry about A breaking the rule. Same thing with B. Helios is not in B, which means that rule is not broken because it's not even triggered. What about C? Helios is selected in C, which means Q and I should both be off the page in C, but they're not. Quisling is in C, which means that breaks the rule because H is in, and Q and I should both be out, but Q's not, which means C breaks that rule, which leaves us with A and B. Next rule says if G and S are both in, then I has to be out. A, I see that G and S are both in, which means I should not be selected, but it is, so A breaks that rule, which means we're left with B. And of course, B follows that rule, right? We already know that B is the answer, but if we just look at that rule, G and S are not both selected in B, which means that rule isn't even triggered, which means it's not broken. And even though we're done the question, we might as well look at the last rule for B, which tells us that if F is in, then either S or V, but not both, have to be in. In the case of B, F is in, Funscape is selected, and we do have one of S or V. We have salvation, but we don't have verisimilitude, which means B does follow that rule. Of course, we already knew that because by process of elimination, we already knew that B was the right answer. So that's it for number 13. Number 14, if I is not selected, then each of the following pairs could be among the selected paintings except. So first things first, we make the if true and we look for inferences. So we know that in this question, we're going to be putting I as one of the not selected variables. Let's look for inferences. So the way to find inferences with conditional rules, as we said at the beginning, is did we make any beginnings of arrows true, or did we make any ends of arrows false, right? If we made the beginning of an arrow true, then the end would have to be true. And if we made the end of an arrow false, then the beginning would have to be false. But in this case, the only rules that I is in are these two rules. And in both of those cases, we did something that made the end of the arrow true, right? In this one, we didn't make it fully true. We made it partially true. But either way, that's not going to tell us anything, right? The only way that we can make an inference from something to do with the end of an arrow on a conditional rule is if we made it false, right? That's how contrapositives work. If you make this false, if I were not there, then we would have to know that G and S would not be there. But if I is there, that doesn't tell us whether G and S go there or not, because they could, and that would follow the rule, and they could also not be there, and that would also follow the rule, which means we have no inferences. So we have to go ahead and start testing out the answer choices, right? Because those were the only two rules that have I in them, and in neither of those rules do we have any kind of inference here. So each of the following could be selected, could be among the selected paintings except. So let's go ahead and test them out. This is essentially a cannot be true question. Which of the following cannot be in the in group? Let's try A. Let's try to put A in the in group, Q and R. So if we put Q and R in the in group, let's go ahead and look at the rules. Well, let's see, if Q is not there, we just made the end of that arrow false, right? Because the end of that arrow is that Q and I would have to both be in the out group if H were in, but they're not because Q is not in the out group, which means we have to make this false as well, right? We would have to put H out in order to not trigger that rule so that we don't break it. Now, let's see, anything else? Well, we made the end of this arrow true, which means we could make the beginning true, but we don't have to. That rule is going to be fine. What about this? We don't really know about G and F. Let's just go ahead and put F in just to make that simple, right? So we don't have to worry about breaking that rule no matter where G goes. And then we trigger this rule, but that should be easy to do. We can go ahead and split up V and S. We can, let's say, put V there and S over there. We are left with G, which would go in. This wasn't the only way that we could have done it, but as long as we have some way of doing this where all the 8 letters go somewhere and where we followed all the rules, let's just check them all to make sure. We triggered this rule and we followed it. We put F in. We triggered this rule and we followed it. That's fine. We made sure not to trigger this rule, so that's fine. We did not trigger this rule because G and S are not both in. And this rule we triggered and we followed. So therefore we followed all the rules in A and it works, which means A is not the answer. So let's look at B. Could S and G have been in here? Well, let's see. S and V, if you recall, we just arbitrarily split them up, but we could definitely switch it around here where that's an S and where that's a V, and that wouldn't have changed anything. All the rules are still followed, which means B is also not the answer. B also works. What about C? Could V and G be in? Yes. V and G we already put in together, so therefore we don't need to do anything for C or for B because we already have information on the page that shows that they could be true. Same thing with E. R and G were both in the scenario that we have, which means A, B, C, and E are all things that could be true. Thus, by process of elimination, D is the answer, so we are done. But that being said, let's go ahead and see why D is the answer. If we had I out and we tried to put S and V in, why doesn't this work? Well, let's see. It triggers a couple rules. First of all, if V is in, that means Q and R have to both be in. Second of all, this rule, we just made the end of the arrow false, right? Because if F were in, S and V would have to not both be in. They'd have to be one of them in and one of them out. Since they're both in, we can't trigger that rule, which means F has to go out. Now, putting F out triggers the end of that rule. We just made the end of that arrow false, which means now we can't put G or H in, because if they were, that would force F to be in. So we'd have to put G and H both out. Of course, that doesn't work. That's too many letters out, so that doesn't work. That's why D is the answer, but we already knew that anyway by process of elimination. Let's look at number 15. If both F and H are selected, then which of the following pairs must also be selected? So as always, when there's an if statement, we start by making the if true and looking for inferences. So if F and H are both in, are the rules forcing anything else to be true? So there are a couple fairly obvious inferences here because we triggered a couple of rules here. First of all, we made the beginning of this arrow true. We put H in, which means the end of the arrow has to be true. Q and I have to both be out. Second of all, by putting F and H in, we also triggered this rule. We made the beginning of that arrow true as well. F is in, which means S and V have to be split up. One has to be in and one has to be out. We also put Q and I out, which let's see if that triggers anything else. And it actually does, because look at that. This rule, the end of the arrow involves Q and R both being in. So we made the end of that arrow false, right? It doesn't matter where R is because Q is already not there, right? Let's think about it. If that rule were triggered, if V were in, Q and R would have to both be in. So therefore, there's no way that V can be in because that would force Q and R to both be in. We already know that Q's not in. So regardless of where R is, it doesn't matter. We already know that since Q's not in, we must not trigger that rule, which means V has to not be in, right? The end of the arrow is false, which means the beginning of the arrow has to be false. And just to clarify, the end of the arrow is partially false, but that's just as good as fully false, right? If it's partially false, there's no such thing as half true and half false. If it's partially false, that means it's false, right? So since Q is not where it's supposed to be, that means V cannot be where it is in that rule either. So that means that V has to not be where it is to trigger that rule. V would have to be over here. So this V slash S can now be resolved. We know that the V would have to be the one that's out in order to not break that rule, and the S would have to be the one that's in. Now, are there more inferences here? Well, let's see. We filled up our quota, right? We know that there's always 3 things in the out group. And that's why it's very important to always show not just the in group, but also the out group in these in and out games, because very often we have quotas for each group. And once we hit the quota of the group, well, then guess what? Our work's done. We know that since the out group is already full, all the other letters must be thrown into the in group no matter what. So what's left? Let's see, we have F, H, S, Q, I, V. So what's left? Let's see, there's so many letters. G and R are the 2 letters left. They would have to both be selected. So this is what number 15 would look like. We made the if true, and we found all the inferences, and we basically, not basically, we 100% determined exactly where everything goes. So which of the following pairs must be 2 of the selected paintings? Well, let's just look through them. I and R? Nope. I is out. Same thing with B, not I and V, because I is out. I is not selected. Same thing with C. Q and S is not true, that they both have to be selected because Q is not selected, right? So A, B, and C are all wrong. D, R, and S. Yes, R and S are both selected. Those both have to be in, as we just proved, which means D is the answer. And then, of course, E is not the answer because E is R and V, and we know that V is out. So, as we can see, D is the one that must be true. D is the pair of letters that have to be in here, as we just proved by finding all the inferences. So D is the answer. Number 16, if both Q and V are selected, so let's make the if true, which of the following could be 2 of the other selected paintings? So first we're going to make the if true and look for inferences. If Q and V are in, let's look at the rules. We obviously know that if V is in, then Q and R have to both be in. Q's already in, but the point is that R has to be in as well. And let's see, have we triggered any other rules? Remember, the way we trigger a conditional rule is either by making the beginning of the arrow true or by making the end of the arrow false. So essentially, have we made any other beginnings of arrows true and or have we made any other ends of arrows false? The answer is yes, we did make an end of an arrow false, right? This end of this arrow. Q and I are not both out because Q is not out. Now, it doesn't matter where I is, right? We made it partially false, but partially false is as good as false, right? Because if H were in, if the beginning of that arrow were true, Q and I would have to both be out. Since they're not both out, right? I know that Q is not there. Q is over there. Then it doesn't matter where I is. I know for sure that the beginning of that arrow has to be false. H cannot be in because if it were, it would break that rule, which means H has to be out. Let's see, any other rules triggered? The answer seems to be no, right? This last rule, the end of the arrow is S and V, one of them being in and one of them being out. We know that V's in, but we don't know where S is, so we don't know if that's triggered or not, and therefore we can't seem to find any other inferences. So that's making the if true and looking for inferences. Let's look through the answers. Which of the following could be 2 of the selected paintings? Well, anything with Helios in it would be wrong because we've just proven that Helios has to be out. So we can immediately cross off A and E because they contradict with what we have on the page. Let's test out B. Could it be S and I? Well, let's see. If it were S and I that were in, that's all 5 of the in letters. It would have to be because we are only allowed to have 5 in the in group. So that means whatever's left has to be out. So what are we left with? Q, V, R, S, I, H. We are left with, let's see, F and G. There's so many letters, so it's hard to find them sometimes. So this is B. Let's just see if this follows the rules. If it does, then it's the right answer. So going through these one by one, this first rule we did not trigger. We didn't put G or H in, so we don't have to worry about that. This rule we already took care of when we made the if true. This rule we also made sure not to trigger when we found the inferences. This rule we did not trigger because G and S are not both in because G is out. So that's nothing to worry about. And then finally, this rule we didn't trigger because we didn't put F in. So therefore, since we didn't trigger the rule, there's no way to break it. So therefore, B is the answer. We just made B true and it works, which means salvation and incorrigibility could be 2 of the selected paintings if Q and V are selected, which means B is the answer. Now let's go ahead and look at C and D anyway, just to show why they are not the answer, to show why they don't work, even though we really don't have to do this to finish the question because we already know that B is the answer. But let's anyway see what it would have looked like to test those out. So we would have started like this. Those were the inferences. So C, S, and F, if S and F both went in, that would immediately give us problems with this rule because F is in, which means S and V have to be one in and one out, but they're not because they're both in this situation. So that would be something that would break the rules. And what about D, G, and I? If G and I were in, well, we triggered this rule because G is in, and that means that if either G or H are in, that means that F has to be in, which it's not. It doesn't fit in anymore. We already have all 5 of the in letters, which means F would have to go out. That would break the rule. That was D. At any rate, we just showed how C and D both break a rule, and therefore they're impossible, but we didn't have to do that. We already knew that B was the answer to number 16. Number 17, last question. If Q is not selected, then which of the following pairs must be selected? So generally speaking, we would always start by making the if true and looking for inferences. However, there might be a shortcut here because we have a scenario on the page where Q was not selected. That was number 15. So we've made this if true in the past, right? Now, if we can find any of these answer choices that we made false in number 15, that would prove that they're not the answer, right? That's how you test out answer choices in a must be true question, as you know, by making them false, right? If A must be true, then that means if we try to make it false, we won't be able to. Same thing with B, C, D, E. So if you've made any of these false, then you know that they don't have to be true. So let's see how lucky we are. In number 15, we made the if true, and we put Quisling as not selected. So if we made any of these answer choices false, we would know that they're not the answer. So was A true in number 15? Were S and V both selected? The answer is no, because V is out. So we're already pretty lucky. We know that A is not the answer because, again, you can't tell me that if Quisling is not selected, then S and V have to be selected because we've already violated that. They weren't both selected in number 15. And same thing with any other answer choice that has V in it, namely C, right? A and C both have V in them. And we know that V was out in number 15, even though Quisling was not selected. So therefore, you can't tell me that A is the answer, and you can't tell me that C is the answer. They're both wrong. And look at the other letter that was out here, I. The other 2 answer choices here both have I. The other, or 2 out of the other 3 answer choices, I should say, both have I, right? That's D and E, which means D and E are also both wrong. So we got very lucky here because we don't have to actually do any work for number 17. As you can see, in number 15, we made the if true. We put Q out, right? Quisling was not selected. And we made A, C, D, and E all false, right? Which of the following must be selected? Not A, not S and V, because V is out here. Not C, not R and V, once again, because V is out here, right? Not D, not H and I. H and I don't have to both be selected because I was not selected here. And same thing with E. It's not E, it's not that G and I have to both be selected, once again, because I was not selected here. So we made all 4 of those false. So by process of elimination, we know that B is the answer. Now, it's very important to note here, the reason we know B is the answer is not because we made B true here, right? We did make it true. We put R and S both in. That just was the scenario that we did, and we now know that that's the way it had to be. But that wouldn't have been enough to prove that B is the answer, right? Because you never prove that something must be true by having made it true, right? Just because we made it true doesn't mean it has to be true. But if you've made something false, that certainly proves that it doesn't have to be true. So it's not because we made B true in number 15 that we know that it's the answer. It's because we made A, C, D, and E false that we know that B is the answer by process of elimination. And of course, the obvious fact that we also made the if true, right? If we didn't put Q in the out group, then that wouldn't even be relevant for number 17. So at any rate, if we're keeping our eyes on the page, which we always should be, right, for shortcuts, then we know that B is already the answer. We don't actually have to do any work for number 17. That being said, let's say you hadn't noticed that and you were to start working through this question. Let's just see what that would have looked like. So if Q is not selected, let's go ahead and do it down here from scratch. Are there any inferences triggered? Well, let's see. Since we made the end of this arrow false, Q and R are not both in. That means that V has to be out so that we don't trigger that rule and break it. And I don't think there are any other inferences here, so let's go ahead and test them out. Which of the following must both be selected? Well, we still do have enough to cross off A and C because we clearly see that V has to be out. So V clearly isn't something that has to be in. So we would go ahead and let's say test out B, right? This is a must be true question. So we're going to go ahead and make it false. B says R and S have to both be selected. So to make that false, we have to make one of them not selected, right? So we're going to put one of them, I don't know if it really matters which one, but we can just go ahead. We don't really know which one to put out, but we know that one of them is going to be out, the other one's going to be in, and that's going to fill up the out group, right? Because that's all three of the things that go into the out group, which means everything else has to be piled into the in group. So what are we left with? Let's see, just F, we're left with F, we're left with G, we are left with H, and we are left with I. So is there any way for this to work? The answer is no. If you go ahead and look at the rules, you'll see that we broke this rule by putting H and I both in, right? If H is in, Q and I have to both be out, which proves that B is the answer. We tried to make B false. We tried to not put R and S both in. We put one of them out, one of them in. As we can see, it doesn't really even matter which one we choose to put in and which one we choose to put out. No matter what, it's not going to work, right? If we put one of them out, it's not going to work. It's going to break the rules, and therefore B we cannot make false, which means B is the answer. So that's how we would prove inductively that B is the answer. We didn't have to do that. As we said, we already had that shortcut from number 15, but that's how we would prove that B is the answer because we tried to make it false and it didn't work. So even though we're done the question, and we've now done the question essentially two different ways, let's go ahead and look through the other two remaining answer choices just to show what that would have looked like to test them out. So D and E. So we're going to start again here. I'll just start again over here with, what did we have here? We had Q and V. That was making the if true and finding the inferences. We started with that. So D, do H and I have to both be in? The way that we would test that out is by putting one of them out, right? Now, you may notice here that I is in both of these answer choices. So if you want to have a chance at killing two birds with one stone, you might as well try to put I out. Because if you do, and it works, that means you can cross off not just D, but also E, right? Remember, since this is a must-be-true question, and they're telling you that this is a pair that must both be in, all you have to do is take one of those letters and put it out in order to show that this answer choice may not be the right answer. So in this case, we can put I out, and essentially we're testing out D and E at the same time. So if we put I out, that's, once again, that's all three of the letters in the out group, which means that the out group is full, which means all the remaining letters have to be piled into the in group. So whatever we happen to be left with, it seems like it's F, G, H, and R, and S. So let's see if this works. We'll go through the rules one by one. Rule number one, we triggered, right? We put G and H in, and we put F in, so that's fine. Rule number two, we did not trigger, so that's fine. Rule number three, we triggered and followed. We put H in, and Q and I are both out. Rule number four, we triggered and followed. We put G and S in, and we put I out. And finally, rule number five, we also triggered. We put F in, but we also followed it. We split up S and V, which means we followed all the rules, which means we can make D and E false, right? We didn't put H and I both in the in group, which means D is false, and we didn't put G and I both in the in group, which means E is false, which means E is also not the answer. So just by putting I out, we managed to test out D and E at the same time. Now, you may notice that, guess what? This is exactly the same scenario that we had over here in number 15, right? We put the same three letters in the out group. So we essentially were doing the same thing that we had already done. So as you can see, if we would have noticed that we had done that in number 15, it happened to be that we would have found the answer much quicker. But at any rate, this is how it would have looked like to test out the answer choices one by one. No matter how you do it, you should see by now that B is the right answer to the question. If you found this video useful, don't forget to hit subscribe. And for thousands more clear LSAT explanation videos, go to masterlsat.com.